Hi, good morning, everyone. My name is Ravi. I'm the co-founder CEO of Zeeve. And today in this webinar, we are talking about proof of stake blockchain staking with focus on both individual as well as institutional staking. So first of all, a brief about staking. What staking is. So staking is a very general term in the blockchain space. But this webinar is focused on POS blockchain staking. So there are various ways today by which liquidity providers are providing liquidity to various platforms. So whether it be providing liquidity as in the form of staking to the POS blockchains, or providing liquidity to various decentralized exchanges or lending protocols. So there are various ways where you can provide liquidity and earn rewards for providing liquidity. Blockchain staking or validation on the blockchain is one such area, which is in fact the biggest area within the blockchain space. And so earlier when Bitcoin came in, and to a larger extent before Ethereum upgraded to 2.0, they were using proof of work as a consensus. And in the case of proof of work, what happens is that there are a set of miners who participate in verifying and writing the transactions on the blockchain in the form of a block. And proof of work is distinctly different because there is a puzzle that everyone needs to solve. So each miner actually work to solve that puzzle, and whosoever solves the puzzle first gets to write the block and earn rewards. Now, there were various challenges in proof of work. One, since there's a competition to solve the puzzle, slowly it increases the stake on each of the miners' side to continue to invest into better technology, better hardware, to get more hash power. So and it was leading to a lot of wastage of energy. And at the same time, in case of proof of work, what happens is every miner tries to solve the puzzle. So it's not just one person who is going to write the block is doing the work, but every miner is doing the work and only one of them wins. So the work done by the other miners pretty much go as a waste. So these were some of the challenges which proof of stake solves. And proof of stake as a consensus algorithm became very prominent. Today, if we see, majority of the blockchains are using proof of stake as the consensus. And within proof of stake, there are various variants. Delegated proof of stake is one of the most common, where you have validators and then you have delegates who are supporting the validators. I'll come about that later. So there is not energy wastage. Proof of stake works on where validators or stakers, they stake the native tokens into the blockchain and they become a validator. Every blockchain has got their own criteria of how to set up the node, what kind of number of tokens that they need to stake, what the staking reward will look like, and so on and so forth. So so that is why proof of stake blockchain has become a common means by which, whether it be individuals or organized liquidity providers, they use proof of stake as a means to invest and earn rewards. So how does staking work in proof of stake blockchain? So let's say, and this is a plain vanilla description. There may be variants to different blockchains, but largely the process looks like this, where a validator, as they are called, they stake their native tokens in the staking pools, or they set up their own node. So there are various ways, like we used to have mining pools. Similarly, if you want to become a validator, you will set up a validator infrastructure, you will put in a certain stake. So for example, let's say Avalanche requires minimum of 20,000 AVAX to become a validator. So you need to stake 20,000 AVAX, And then, out of all these validators, there are, let's say, thousands of validators. And out of these validators, there's a random selection of who is going to be the next validator for the next block. And then, the selected validator then verifies and processes the block of transactions. And in this case, what other validators do, they verify and approve the transaction. So there's a check and balance where the selected validator, does its own check, but then the other validators also verify and approve the transaction. Once it has been verified and approved, then the block is written on the chain, and the selected validator earns the rewards for that. And then this keeps on changing with every block. So if, let's say, the block is written every second, so every second this process happens, and rewards are given to the selected validator. And the rewards are again given back to the same wallet in most of the cases. At times, it allows you to define a different wallet. So at the time when a validator puts on a stake, at that time it defines in which wallet they will receive the rewards. Most of the cases, the same wallet they have used to stake the native tokens, they will receive the rewards within the same wallet. And then, there are various options. You can choose to continue to reinvest the earned rewards. So your overall stake amount increases. And of course, accordingly, reward also increases. It's called compounding. Or you can choose to withdraw your rewards regularly so that your staking amount remains pretty much the same. Now, why institutional staking or staking per se has been on rise? It has been very popular in the last 2 to 3 years. So the reason is that, especially if you talk about some of the established blockchains or even new blockchains, they provide very good rate of returns, which typically in the staking world, it's called APY, annual percentage yield. So annual percentage yield is typically in the range of 4 to 5% to even going up to 20-30%. I'm talking about where the risk is comparatively low. And vis-a-vis that, if you see in the traditional world, the investments, even if you see AA or AAA rated bonds, the annual percentage yield is very small. And that is the reason, blockchain-based staking has become a very attractive proposition for quite a few investors. Of course, due to the volatility in the price of the native token, there is an inherent risk in the case of blockchain-based staking. But still, overall, if you see the historical returns, they have been more than the traditional investments. So there are various reasons. As I mentioned, one, there's a passive income on assets. So what happens is, let's say there's an investor, they have invested into like a lot of people are now building a small percentage of their portfolio in crypto assets or digital assets, and you're holding those assets, but there is no way to earn passive income on those assets. The only way you can do that is to use those assets, whether to provide liquidity on decentralized exchange or lending protocols, or you can provide, you can stake into a blockchain as a delegator or as a validator and earn passive income on that. So basically, any asset which is sitting idle in your wallet, you can earn passive income on that. And second, it gives you a compounding option. So it's pretty much so simple that you stake once and then forget. In fact, most of the protocols now offer an option where you can select an option of compounding. So automatically, whatever rewards are coming in, they will be auto reinvested into your stake and continue to earn rewards. And there is a locking period, but beyond the locking period, you can always withdraw. So you can stake, unstake at any point of time, keeping in mind the locking period. And one interesting thing as compared to lending protocols, etc., is that in the case of POS staking, you're not giving away your assets. You hold the custody of your assets. It's just that you're locking those assets when you are staking the assets into a chain. And the purpose of if you see from a protocol side, it helps the protocol. One, you as a validator are securing the chain. You are verifying all the transactions. So you are helping securing the chain. As the number of validators increase, spread across different geographies, you help in improving the decentralization of the blockchain. And at the same time, by locking these tokens, you also reduce the circulating supply in the market for a protocol. So that way it's easy. So because a protocol can always see, or anyone can see how much liquidity has been locked into staking for a specific protocol. Based on that, it can lead to some price stability. Because if majority of the tokens are locked, then you have a clear visibility on how the token price will be affected. Now, this is which I mentioned, is true for whether you are staking or validating as an individual, as a startup, or as an organized fund. Now, but how institutional staking is different? It's just the size of the stake. When we talk about institutional staking, we are talking about millions of dollars of worth of tokens that are being staked, vis-a-vis an individual who may be staking $10,000, $20,000 worth of staking. Setting up a single node across one or two blockchains, POS blockchains. But when we talk about institutional staking, we are looking at organized funds who are staking billions across different blockchains, and may not be just one node. There may be multiple validator programs they may be running. So there's a large-scale participation, like banks or hedge funds or asset management firms, etc. So they invest millions of dollars, and of course they require everything to be successful, because the stakes are very high. So there are various ways of how an institutional organization or institution can get into staking. There are various type of options, how to set up the infrastructure, how to manage the stake, like whether you use a third-party custodian or you do a self-custody of the assets, you are managing everything in-house, or you're using various third parties to manage the infrastructure or the custody of assets, or in fact, the overall process of validating. So, and then, in the case of institutions, they of course need to be very clear about the risk involved vis-a-vis the returns. And at the same time, they also need to be very clear about various compliances that are required, so that they can adhere to all the regulatory compliances and so on and so forth. So that's why institutional staking becomes very complex, and it needs to be done in the right way to ensure the rewards that are being promised on the POS staking. So if you see, these are some of the established blockchains today and some of the new ones like Korea, where, and I'll define some of these words later in the webinar. So if you see, these returns are given 1 to 18% or 5.59%. These are called APY, annual percentage yield. And so these are the reward rates across different blockchains. And there's an inflation which is given. Inflation means how many tokens are being put into circulating supply. The option of slashing. The slashing is the method by which a bad actor is penalized. So when you put a stake, you may be a bad actor or maybe a unreliable actor. So if the infrastructure is not up and running most of the times, or somebody do any kind of double submission, etc. So their stake tokens may be confiscated. So that is called slashing. So slashing is more of a disincentive or punishment for doing something wrong while doing staking. And then there's a lockup. So you see, like in the case of Ethereum, a year, but like 5 days to 28 days in Polkadot. So different blockchains have got different locking periods. So by locking period, what it means is when you stake, it will be locked for that much time. And then post that time, you can continue to stake, or you can unstake. So that is another value of it vis-a-vis security. It's like a short-term fixed deposit, where beyond the locking period, you can anytime stake, unstake. So outlining various risks associated with institutional staking. So one, as I mentioned, is the whole custody piece. The second is maintenance of the network itself, the whole hardware, the infrastructure, the software, etc. Third is slashing, how to ensure that there is no disincentive or slashing that happens, and various other considerations that I'll cover. So first, talking about the custody risk. So that is the biggest challenge. When you start your validation process, who is going to be the custodian of the asset? The option one is that, you do it yourself. So you need to set up the in-house infrastructure. At the same time, you need to have a know-how. You need to have a higher expert, a team of experts to understand managing infrastructure. And infrastructure becomes more complex because every blockchain has got different way of dealing the infrastructure. Yes, in case of most of the EVM compatible chains, there may be some commonalities, but still every blockchain has got its own criteria, like the minimum hardware requirements to different kind of code base, so different APIs, etc. So for each blockchain has its own nuances that need to be taken care of, and the internal team has to continue to upgrade themselves whenever they want to expand to various blockchains. The second option is using a third-party custodian. But the major risk with using a third-party custodian is that, the funds may be at risk. If anyways, custodian is not reliable, or something goes wrong with custodian, they mismanage the funds, like what happened in last year with quite a few players. So then in that case, the funds may be at risk. But yes, now most of the custodians which are coming in, they are properly licensed and they have regulatory approvals. They're operating from developed economies, and they follow all the rules of the land. Whatever rules are, whether from the central bank or from the government. So this again this is on the rise. Many organizations, they use third-party custodians to manage the assets. But slowly and slowly, since the stakes are very high and there's a custodian fee also involved. So a lot of people are trying to manage using self-custody wallets. They are trying to self-custody these assets. And then, sometimes you may use, like the way we have used health management organizations traditionally, you can use a third party to manage the complete validation process for you. That again, of course, become a riskiest process, but it's most cost effective because you do not need to set up your own infrastructure. You don't need to go through the whole process, and you can be up and running very quickly. So this again is a method that quite a few use. But most of the times what we have seen is, people prefer to own their own infrastructure, run their own validator nodes with some help from third parties where there is hardly any risk. And the second, they use third-party custodian to manage the assets, assets into cold wallets, etc. But rest of the process, they run themselves. In terms of maintenance, now, one, as I mentioned, if you want to stake on multiple blockchains, each blockchain may come with its own nuance. So there are EVM compatible chains, there are substrate chains, there are non-EVM, non-substrate chains. So there are a plethora of options, and if you are a large organization staking across different blockchains, of course, there's a learning curve which gets involved. But apart from that, each blockchain per se continue to have a lot of updates and upgrades. And whenever an update or upgrade happens, sometimes you need to recompile the whole binary. So those updates need to be done on the infrastructure also. So there may be base software updates, there may be network-related changes or some security patches. So all these changes need to be done. And at the same time, it needs to be ensured that the node doesn't go down. There's no downtime involved while making those changes. So again, a proper infrastructure needs to be designed and architected and deployed so that these kind of challenges are not there. Because as I mentioned, if the network if your node goes down, one, of course, you're not participating for that specific period of time into staking and losing the rewards, potential rewards. So your tokens become idle. And second, you may be penalized for being down. So the infrastructure is down. That again may be a reason for penalizing. Now coming to the topic of slashing. So slashing, as I mentioned, is a penalty mechanism where whatever you have staked, the percentage of that stake can be confiscated by the protocol. And there are various reasons why this can be done. So one, as I mentioned, there's a downtime. And the second is double signing, which is even more dangerous. So what downtime is, your node network is down due to any reason, and it is not participating in the validation process. And this, of course, just imagine a scenario where a blockchain is running with a minimum number of validator nodes, 30, 40 validator nodes, and 50, 60% of them goes down. It may put the entire blockchain network into risk. So that's why every blockchain wants, one, to have more and more validator nodes. But initially, when a new blockchain start with a small number, and then slowly and slowly they onboard various validators who are interested in securing a chain. In fact, this is one of the biggest hurdle while launching one's own layer 1 or layer 2 blockchain. So by increasing the number of nodes, of course, even if one node go down for a certain period of time, it does not have any impact on the network. Still, it is considered wrong from a network perspective. And that's why there's a penalty involved whenever there is a significant downtime. Second is double signing. So double signing is that, sometimes what happens is, to keep your node up and running, you may have a load balancer. There are two nodes which are running with each other. And you may, if the design has not been done correctly, you may submit the same block twice, using the same signature. Then again, it may trigger slashing, because it is considered completely wrong or improper from a consensus perspective. And there's a method of, concept of whistleblowers where, other nodes in the network can report any such wrongdoing by a bad actor. And they are incentivized to do this. So there's a proper disincentive structure in the form of slashing. And there's a incentive structure where other people can keep a tab on what is happening on the network. Last week, when I did a webinar on rollups, optimistic rollups and ZK rollups, so there again, the concept of validity proofs and fraud proofs is based on this, that there are various parties who are incentivized to ensure that no bad actor is able to perform any improper action on the chain. So downtime, as I mentioned, the slashing happens whenever the node is down for a significant period of time. It's not that, it's down for a second, but if it's not able to participate in the consensus for a considerable period of time, there may be slashing that may be involved. And then there is a double signing. Double signing, the slashing will be more than in the case of downtime. Some blockchains are even very harsh. If there are certain wrongdoings, they may trigger 100% of the stake. But most of the time, it's a percentage of stake that gets penalized. But just imagine if you have put in millions of dollars worth of stake, even 2 to 5% is a significant amount, because that's a principal amount of money. So percentage of principal is, of course, a very large amount. Just imagine you have put in $1 million and you are making 5% or 6% as APY, and you have been penalized for 5%. That means completely losing the profits for a year, right? So that way, slashing becomes a very important factor to remember whenever you are setting up a validator, institutional grade or enterprise grade validator infrastructure. The other considerations are, set up an educational time. As I mentioned, each blockchain comes with its own nuances. So of course, and they need to be continuously maintained. There are various updates that happen. So of course, the team continually needs to update themselves with necessary skills and expertise to manage these different blockchains. And if you continue to add more newer blockchains, some are based on Cosmos SDK, some are completely new. So there may be even more learning curve that may be involved. And then, there's a cost analysis, because unless it's a very large operation where staking millions of dollars across each blockchain, then of course, setting up our own infrastructure, setting up a large team makes sense. Otherwise, it's always build versus buy kind of decision that happens here. If you're staking comparatively smaller amount across only few blockchains, sometimes, setting up your own infrastructure, getting involved in the capex, having those hardware, etc., does not make any sense. So a proper cost analysis also needs to be done to see that whatever cost of doing business or doing staking is not cutting down on your APY. And then, unbonding period. Some blockchains, have got a larger bonding period. So depending on the fund usage and fund availability, this also needs to be taken care of, that what is the bonding and unbonding period, so that accordingly you can choose the right set of blockchains or the amount of funds that you want to invest in any of the blockchains. So now, what are the different options? How the way enterprises, do staking or institutions do staking? One is, as I mentioned, go self-hosted. So that means you manage the infrastructure, you manage the custody of your tokens, everything is completely in-house. As I mentioned, this option is pretty good because you reduce the risk to a large extent. But at the same time, it comes with its own set of challenges, like you need to continuously upgrade yourself in terms of team expertise, continue to invest into hardware, infrastructure, etc. And also need to ensure how to manage the private keys, etc., so that they are not stolen or hacked into. The second is custodial solutions or delegation route. So custodian solution, as I explained, you use a third-party custodian solution who can, manage the custody of the assets. Now, there is inherent risk in doing that. The custodian may fail. So that is the biggest risk. There's another route called delegation. So quite a few blockchains have got a concept where there are validators and then there are delegates. So for example, let's say Avalanche. Now you need to, for becoming a validator, you need to stake 20,000 AVAX. So at today's rate of about $16-17 per AVAX, it means minimum stake of $35,000-40,000. But then again, with a minimum stake, there are less chances that you would be selected as an active validator. So then the stake amount also goes high. So for smaller validators, it's not possible to get into the whole staking business by becoming a validator. So there's a concept of delegate. They can become a delegate, and in delegate, there's the minimum is pretty much like nothing, and so one can invest whatever they want to invest as a delegate, and they can choose a validator. So delegates are people who are actually selecting or aligning with a validator, and whatever stake the delegates put in, that stake get added to the validator stake. So validators have an incentive to bring in more and more delegates because their overall stake increases, and whatever rewards they get, they share a percentage of that reward with the delegates. So that way, if a validator share more rewards with delegates, of course, they are bound to get more delegates. So delegation route is another route that is completely pretty much riskless. If you are aligning with the right set of validators, there are no chances of slashing, etc., or reduced chances of slashing. So delegation is pretty simple, and any kind of amount can be invested into it. The third is become a white label validator. That means you use third party wherever required. Like, setting up a non-custodial infrastructure is one way, which is pretty much risk-free because it is non-custodial infrastructure. Still, you're removing all the hassles of setting up your own nodes and going through the learning curve of and different blockchains, and at the same time, continue to maintain and update those nodes over a period of time. So that is a third option where you can use a third-party infrastructure provider to provide non-custodial nodes, also called white label validator nodes. So that is where Zeeve comes in. Zeeve is one of the leading players in the world to provide white labeled or non-custodial staking infrastructure. So one, it's an enterprise grade infrastructure. Zeeve being an ISO 27001 SOC 2 compliant organization, very high on security, providing an enterprise grade security to all the node infrastructure. There's an uptime guarantee. We have designed an architected solution which have been vetted by the likes of AWS. So to ensure that there's a 100% uptime for all the validator infrastructure. All the infrastructure that we provide is non-custodial. So at any point of time, we never take custody of assets or private keys or any on behalf of any of the customers. So they are purely non-custodial. We are just managing the underlying infrastructure. So that, and the way, we work with almost 9 cloud providers across 100 plus regions across the world. So we ensure decentralization, a complete distributed architecture. And, since we have designed the architecture in such a way, it reduces the risk to a very large extent. And we support 40 plus blockchain protocols. If you talk about all the established ones like Ethereum, Polygon, Avalanche, Near, etc., to all the new ones like Shardium, At.the, Corium. Recently, we have added Telos. We are also going live with Su blockchain and so on and so forth. So this is pretty much I wanted to cover, and I can take a few questions. So one question is, one question is, I have a validator set up on Zeeve platform already, and do I need to do anything to maintain that VM, or it's fully managed service? So yes, all the node services on Zeeve are fully managed. So now one is managed service in the sense that we ensure the uptime of the nodes. Now there are 2 options that we have available, but right now for validators, mostly it's a managed service, 100% managed service. So we ensure the underlying infrastructure will always be up and running. Apart from that, the validator needs to take care of it. But the underlying infrastructure, which cloud it is running on, everything is taken care of by Zeeve. Now, Pulse Chain, I need to explore. So we have a dedicated team which continue to work with newer protocols and partner with them, add their support on our protocol. So thank you for pointing out Pulse Chain. I'll check with my team to see if we have Pulse Chain already as part of the roadmap, or else, we would love to explore Pulse Chain and see, we can provide that. But generally speaking, if you have any custom blockchain in mind that we do not support as an automated or automation platform on Zeeve, you can always request us and we can always do that. If it's a EVM or Substrate or Cosmos-based chain, we have solid expertise on any new chain using any of these, part of any of these ecosystems or VMs. We can easily add that. And even if it's not, then also there will be some setup time involved, but we can do that. Yeah, so right now we are working with our insurance organization to involve insurance for, we have taken insurance for any cybersecurity hacks, etc. So there's a very comprehensive insurance we have taken. But specifically for slashing is something that we have now applied for. And we are sure that in the next few months' time, we'll have a proper insurance covering these slashing also for all the nodes which are completely managed by us. Any other question? So if there are no further questions, thanks a lot to everyone who attended the webinar today. We will be posting a copy of this webinar on the website. So anyone who has missed this webinar or want to, go through the webinar again, can check our website. And do join us on Discord, Telegram, Twitter, and LinkedIn. We are doing a lot of Web3 initiatives in India, Middle East, Europe, and US. And if you want to connect with me, you can connect with me on LinkedIn or email. And me or my support team would be very much willing to work with you. Thank you. Yeah, so Janine, if you can drop a Telegram message or connect me on LinkedIn, I'll surely talk about Pulse Chain with my team and get back to you. Thank you. Thanks, everyone. Keep smiling, keep building.